Multiply each expression and simplify. In exercise A, we have the square root of 3 plus 2 times the square root of 6 plus 5. So I'm going to apply multiplication of polynomials, the FOIL concept here, and I would have the square root of 3 times the square root of 6 plus the square root of 3 times 5 plus 2 times the square root of 6 plus 2 times 5. Square root of 3 times the square root of 6 is the square root of 18. And then the square root of 3 times 5 is same as 5 times the square root of 3, plus 2 times the square root of 6, and 2 times 5 is 10. Now the square root of 18, I can think of 18 as the square root of 9 times the square root of 2. And the square root of 9 is a perfect square, yielding 3 times the square root of 2, plus 5 times the square root of 3, plus 2 times the square root of 6, plus 10. We have no like radical terms, so we would leave this as it stands. Exercise B, we have the square root of 7 minus 3 times the square root of a minus the square root of 7. Again, applying the FOIL concept, I would have the square root of 7 times the square root of a minus the square root of 7 times the square root of 7 minus 3 times the square root of a plus 3 times the square root of 7. The square root of 7 times the square root of a is the square root of 7a. We can bring both of those under the same radical. The square root of 7 times the square root of 7, that's the same as the square root of 49. 7 times 7 being 49. Minus 3 times the square root of a, and plus 3 times the square root of 7. And we can simplify the square root of 49. The square root of 49 is simply 7. So I can write this as the square root of 7a minus 7 minus 3 times the square root of a plus 3 times the square root of 7. There are no like radical terms, so we will leave this one as it is. In exercise C, we have 4 times the square root of 3 subtract 5 squared. So we have the square of this quantity, and so I will write this out as 4 times the square root of 3 minus 5 by 4 times the square root of 3 minus 5, and apply the same concept as in the previous exercise. So then I would have 4 times the square root of 3 times 4 times the square root of 3 outers minus 4 times the square root of 3 times 5, inners minus 5 times 4 times the square root of 3, and then last I'd have plus 5 times 5 is 25. 4 times the square root of 3 times 4 times the square root of 3, 4 times 4 is 16, the square root of 3 times the square root of 3 is the square root of 9. Minus 4 times the square root of 3 times 5, the 4 times 5 is 20, so I'd have minus 20 times the square root of 3. Similarly, on the third term, another 20 times the square root of 3, and then I'd have a plus 25. Now 16 times the square root of 9, the square root of 9 is 3. All right, the square root of 9, that's 3. So I have 16 times 3 is 48. Minus 20 times the square root of 3, minus 20 times the square root of 3, so that's minus 40 times the square root of 3. Those are like radical terms, and still plus 25. And so then, combining the like terms, 48 plus 25 is 73. So I have 73 minus 40 times the square root of 3. Now, if you recall the special pattern for squaring a binomial, if you remember that a minus b squared is a squared minus 2ab plus b squared, you can use that pattern to simplify the expression as well. So here we have 4 times the square root of 3 minus 5 squared. I can think of that as 4 times the square root of 3 squared minus 2 times 4 times the square root of 3 times 5 plus 5 squared. 4 times the square root of 3 squared would be 16 times 3 minus 2 times 4 times 5 minus 40 times the square root of 3 plus 25. 5 squared being 25. And notice again that 16 times 3 is 48, and we get the same result. So knowing that perfect square trinomial pattern can still be useful.